All right, so let's move on now to question two. Question two is, what is the literal strength of the line of regression? Now, all we need to do is come up with the correlation coefficient and plug it into this table and get our literal translation or literal description, okay? So, how do we get the correlation coefficient? So if we're going to do it on the Texas Instruments calculator, we want to run linreg ax plus b, and that'll give us the correlation coefficient. Now, for this to work, again, I want to reiterate, you need to go into mode and make sure that stat diagnostics is set to on. Okay, so let's quit out of this. Okay, so we need to run linreg ax plus b. So we're going to go into the stat button, go to calc menu, and the fourth one down is linreg ax plus b. Hit enter, and our list of x values is in list 1. Our list of y values is in list 2. And I want to graph this. So I'm going to store the line of regression equation in one of these y variables so I can graph it. So to do that, I want to have the cursor here next to store regression equation. I want to hit the vars button, go to y variables menu, function, and I'll go ahead and store that in, let me just change things up. I'll put it in y3. Why not? Okay, so I'll hit enter, and I'll go to calculate. And so now we're looking at linreg, and it's put the line of regression in this format. It gives us a slope, and it gives us a y-intercept, and it gives us our correlation coefficient. Okay. Yeah, which is everything in this screen. So we've got that. Now we sent this over to y3, so it should put it here on this third y variable. So we're going to tap the y equals button to check that out. So let's tap the y equals button, and you can see it put it under y3 with the slope x followed by the y-intercept second. And I think at this point we can just hit graph. And there it's drawing our line of regression through the mean point, x bar, y bar, as a best fit through our scatter plot there. All right. But what we were really trying to get is we were trying to get this correlation coefficient of 0.546, but it just kind of works out at this point. This is the time for Texas Instruments calculator where I can show you how to graph the line of regression. The correlation coefficient we got in the previous question on the NumWorks calculator, but to get this again on the NumWorks, we just need to go to the Stats tab in the regression app. So let's just do that really quick. So here we're already in the regression app. We want to go to the Stats tab. Let's see if I hit. Yeah. So if I just keep hitting up, go to the Stats tab, click OK. And let's see here. I think I can go to the correlation coefficient, and I get 0.546. Okay. So that's how I can get it there. Let's go back over. So again, 0.546. Scroll down. So our line of regression is y hat equals 0.125x plus 67.498 with a correlation coefficient of 0.546. So now we're going to apply this correlation coefficient of 0.546 to this literal translation table. So 0.546 is going to be here between 0.4 and 0.599. So the literal description of our correlation coefficient is moderate. So what that means is the Major League Baseball payroll amount is moderately correlated to the number of season wins. And that makes sense because, I noted earlier, so we got a moderate correlation. Earlier that I said that the scatter points appear to be spread out and not tightly bound. As a result, the correlation coefficient should not be too high. So, these points are kind of spread out, so they're moderately correlated. We got a correlation coefficient of 0.546. And remember, the highest it could go in the positive direction would be 1. So having a correlation coefficient of 0.5 is kind of between 0 and 1. Right, so this is not like the best correlation coefficient we could get, but it's what we have. So I'm going to stop this video here. This is all we needed to do to answer question 2. Let me know if you have any questions.